We're on page 118. We're going to do examples of quadratic equations, and there's 3 examples that we're going to do on page 118. They're shown here, 1, 2, and 3. So we're going to go over what we did on page 117, the introduction, and apply that to these 3 problems on page 118. So let's get started on problem number 1, and here is the equation, quadratic equation. We're going to draw the parabola. So y equals minus 3x squared plus 2x plus 1. The first thing to note is that the coefficient of a is less than 0. Right here, minus 3 is less than 0. It's a negative number, so the shape of the graph has to be a frown or an unhappy face. So when a is greater than 0, it's a smile. When a is less than 0, it's a frown. We did that on page 117, so you can go back and review it. So what we're going to see is that this is a maximum point. When we have a frown, the y value keeps on going up and reaches a maximum value. So let's go over what we're going to do. There are 4 steps here. First of all, we have the equation. We're going to find the axis of symmetry, which is x equals minus b over 2a. And b is 2, so minus 2. And a is minus 3, 2 times minus 3. So minus 2 over minus 6, which is plus 1/3. So the axis of symmetry is 1/3. And here you see it right here with a dotted line, so that one half of the graph, this half of the graph on the left side, is the mirror image of the part on the right side of the dotted line. This cuts it right in half so that the left side and the right side are mirror images. Now, to find the x-intercepts, we have to set y equal to 0 in the equation that we're given. This is the equation, so we set that equal to 0. We rearrange it, so we just rearrange it 1 plus 2x minus 3x squared. I've just rearranged this, and now I factor this. I get 1 plus 3x times 1 minus x. Notice 1 times 1 gives me 1. The inner is plus 3x. The outer is minus x. So plus 3x minus x sums to 2x. And plus 3x minus x gives me the minus 3x squared equals 0 last term. So these are the factors. If I set this equal to 0, 3x equals minus 1 and x equals minus 1/3. If 1 minus x equals 0, x equals 1. So now I have the 2 x-intercepts, which are minus 1/3, right about here, and, or I should say right here, minus 1/3, roughly here, and 1, 0, 1 here. So along the, for the case of the x-intercepts, y is equal to 0 along this line. The intercepts are minus 1/3 and 1. Here we are, minus 1/3 and 1. So now to get the y-intercept, we set y equal to 0. Set x equal to 0 for the y-intercept. The y-intercept set x equal to 0. If x is 0, this term is 0, and this term is 0, and y equals 1. So the intercept is 0, 1. Let's go back here or look down here. Here it is right here, 0, 1. So what do we have so far? We have the axis of symmetry, which is a line running down here. We have the x-intercepts, and we have the y-intercept. So the last point that we want to do is the vertex, and as I said, the vertex is a maximum. You look at the y values. This goes up and reaches a maximum value before it goes down. That's always the case when the coefficient of x squared is negative, and here it's minus 3. So we saw that the x value was a third. It's always obtained from the axis of symmetry. I put this 1/3 back into this equation right here. So I substitute this right into this. Minus 3 times x squared, where x is 1/3 squared, plus 2 times 1/3 plus 1. And, sorry about that. So, now, minus 3 times a third squared is minus a third, because a third times a third is 1/9. Minus 3 times 1/9 is minus 1/3. 2 times 1/3 is 2/3 plus 1. We take the common denominator, 3, we get minus 1 plus 2. And for this one, of course, 3 over 3 is 1. So we're left with 5 minus 1, which is 4/3. So the vertex is the x value, 1/3, and the y value here, 4/3. So, go over this again. Axis of symmetry, dotted line going down the middle here, x equal to a third. Here's the x-intercepts, here's the y-intercept, and here is the vertex, which is a maximum point. Notice that the x-intercept of 1/3 lies halfway between a half and minus a third. If I add minus a third plus 1 and divide by 2 to get halfway in between this and this, I get this minus a third plus 1 gives me 2/3. 2/3 divided by 2 gives me a third, which is the x value of the vertex. So let's now go to example 2. Here we have the graph y equals x squared minus 5. You'll notice that we have no term in x. Well, that's okay. We don't have a term in x, but we must have a term in x squared. So let's go over this step by step. Since the coefficient of x squared is 1, a is greater than 0, so the shape of the parabola is a smile. Here we can see that it's a smile. And we know that ahead of time. The axis of symmetry is minus b over 2a. b, because there's no x term here, is 0. A, the coefficient of x squared is 1, so 2 times 1, 0 over 2 is still 0. So the axis of symmetry is the dotted line that runs where the y-axis here. Right along here, this shown as a dotted line, and that's my axis of symmetry. This half of the graph is the mirror image of that half of the graph. How do I get the x-intercepts? We set y equal to 0, so x squared minus 5 equals 0. X squared equals 5, so x equals plus or minus root 5. So the intercepts are plus root 5, comma 0, and minus root 5, comma 0. The root of 5 is approximately 2.2. It's just a very rough approximation. I put 2.2, but it's very rough, approximately 2.2. So if you go over, right over here, you can see that this is plus root 5, comma 0, and this is minus root 5, comma 0, because I said root 5 is 0. So here's one x-intercept, here's another y-intercept. Now, To get the y-intercept, we set x equal to 0. And if we set x equal to 0, y is minus 5. If I set this equal to 0, y equals minus 5. So the y-intercept is 0, 5 right here. X is 0, y is minus 5. So what do we have so far? We have the axis of symmetry. We have the two x-intercepts right here. And we have the y-intercept right there. When we connect these, you see we can connect these points. When we connect these points, this, and this, we get the shape of the graph. So you always have to connect the points to actually get the graph. Now, the vertex, we calculated the axis of symmetry. We plug this into x squared minus 5, which is so we get 0 squared minus 5. So 0 minus 5. So the vertex is 0 minus 5, which is this point right here, which happens to be the same as the y-intercept. Just a coincidence here. Vertex, 0 minus 5, y-intercept minus 0 minus 5. So it just happens that the y-intercept and the vertex happen to be identical in this case. Now, notice that the x value of the vertex, which is this one here along here, x is 0 right here, lies halfway between the two intercepts. Halfway, here's the negative intercept. Here's the positive intercept, halfway between plus 5 and minus 5. If we add these two, we get 0. We divide by 2, we still get 0. So that's halfway in between. Now, in this case here, you can see that, again, coefficient of x squared is negative, so the graph is going to be shaped like a frown, and the point here is going to be a maximum. The vertex is going to be a maximum. So a less than 0, so the shape of the parabola is a frown. The axis of symmetry is x equals minus b over 2a, and minus b is minus 4 over 2 times minus 2. So minus 4 over minus 4 is plus 1. To get the x-intercepts, we set y equal to 0. So this is equal to 0. I factor out minus 2x from both these terms, and I get x minus 2. Minus 2x times x gives me minus 2x squared. Minus 2x times minus 2 gives me plus 4x. So if I set minus 2x equal to 0, x is equal to 0. If I set x minus 2 equal to 0, x is equal to 2. So the two intercepts are 0 and 2, and of course the y values are 0. So here, 0, 0, and 2, 0. Okay, so we have the axis of symmetry, which is now x equal to 1. We showed that over here. This is it right here. X is equal to 1, the red dotted line. The intercepts are y equal to x equal to 0 and x equal to 2. Of course, along this line, y is equal to 0, which is why this is 0, and that's 0. Now, the y-intercept, we set x equal to 0, and when x is 0, y is equal to 0. So we have also one of the intercepts and the y-intercept and one of the x-intercepts happening to be the same. So the vertex In this case, the vertex, we found it was equal to 1 minus b over 2a. The x value of the vertex is 1. We put that into minus 2x squared plus 4x. We get minus 2 here plus 4, because x is equal to 1, and if x is equal to 1, 1 squared is 1, so we get minus 2 for this term plus 4, and x is equal to, y is equal to 2, so the vertex is 1, 2, which is this point right here. So if we connect this to this to this, we get the shape of the graph. Note that the x value of the vertex 1, x equal to 1, is halfway between 0 and 2. That's always a way to check that you're generally on the right track. So this completes page 118. And